Welcome to the next class of Data Communication Network. In our previous class, we were talking about error detection and error correction techniques. Now, we will talk about an important function of data link layer called data link control. So, when you are trying to combine the flow control and error control of the data link layer, it is referred as data link control. So data link control deals with design and procedure for communication between two adjacent nodes, which we refer it as node to node communication. Along with data link control, the other important function performed by data link layer is medium access control, which deals with how a medium or the channel has been shared between number of devices. So the data link layer is trying to combine the functions of framing, flow control and error control to achieve the delivery of data from one node to another, which we refer it as node to node delivery using certain set of protocols. So framing, flow control and error control are major functions along with node to node delivery. So to implement all this, data link layer is going to use certain set of protocols. The protocols are normally implemented in software by using one of the common programming languages. In our first unit, we discussed that protocols are set of rules and procedures to govern the communication between sender and the receiver. It consists of three elements: syntax, semantics, and timing. So we will be talking it in the coming topics. In the previous slide, we were talking that data link control is the combination of framing, flow control, error control, and using a set of protocols for implementing node to node delivery. But what do we mean by flow control? Flow control refers to a set of procedures used to restrict the amount of data that sender can send before waiting for an acknowledgement. For instance, I have been trying to continuously transmit the data from the sender to the receiver. But if the receiver does not have that capability of receiving, what happens? After a certain extent of receiving, the data will be started overflow from the receiver because it does not have that limit of capacity. So to avoid this kind of scenario, we are trying to implement a flow control to ensure the no data is lost. So each receiving device has a block of memory called buffer, and this buffer is used for storing incoming data until they are processed. But if the buffer begins to fill up, the receiver must be able to tell to sender to halt the transmission. If this doesn't happen, it will be resulting in the overflow of the data. So until it again is able to receive the data, it may to ask the sender to halt its transmission. All this is implemented for a purpose called flow control so that there will be no loss of data. So error control is a combination of both error detection and error correction. It allows the receiver to tell the sender that some of the data sent by it has been either lost or damaged in the transmission and asked the sender to retransmit the same frames. This process is called error correction by retransmission, which we call it as reverse error correction. But if the receiver would like to correct the errors, that would be referred as forward error correction. Error control in data link layer is based on automatic repeat request, which is the retransmission of the data. Now, the protocols which are used by the data link layer are classified into two types. The protocols applied for the first type called noiseless channels and protocols which are used for second type of channels called noisy channels. What do we basically mean by noiseless channels and noisy channels are? If your channels are such a way that there is no probability of occurrence of an error or loss of data, we refer them as noiseless channels. But if their channel there is a possibility of loss of data or error to be generated, that will be called as noisy channel. So we are basically categorizing the protocols to two different types based on the channel used. For noiseless channels, we have two types of protocols called simplest protocol and stop and wait protocol. And for a noisy channel, we have three different types of protocols called stop and wait, go back and ARQ, and selective repeat ARQ. Here ARQ stands for automatic repeat request. So let us start understanding the noiseless channels. The first type of channels which we are referring are called as noiseless channels. So what are noiseless channels? Noiseless channels are ideal channels in which no frames will be lost, duplicated or corrupted. So there will be no requirement of error control for a noiseless channels. Okay, for noiseless channels we have two different types of protocol sets used. The first one is called simplest protocol. The second one is called stop and wait protocol. But before we go ahead for the next protocols, let me understand. In a noiseless channel, no data frame will be lost, corrupted or duplicated. Right. So one of the noiseless channel protocol we are using is called simplest protocol. So simplest protocol is the one that doesn't need any flow control or error control, and it is a unidirectional protocol in which the data frames are traveling in only one direction, that is from sender to the receiver. The receiver in simplest protocol can immediately handle any frame it receives. So after receiving the frames from the sender, the data link layer of the receiver immediately removes the header from the frame and hands that data packet to the network layer, which can also accept the packet immediately. So the first type of noiseless channel protocol is called simplest protocol. So what do you mean by simplest protocol? Now remember, data link layer is in between the network layer and the physical layer. So the data link layer receives the data from network layer which is in form of datagrams, and converts those data into frames, and after converting the data into frames it forwards those frames to the physical layer. And these frames which are received by the physical layer will try to transmit the frames through the noiseless channel to the receiver. At the receiver, the physical layer receives the frame and it will try to forward the frame to the data link layer. So since we are assuming there is no loss of frame or corruption or any duplication, so the data link layer will try to separate the header and trailer which is added at the data link layer of the sender, and will try to transmit the datagram to the network layer. So it's the simplest protocol. You can just find receiving data from network layer, forwarding to the data link layer where it is converted into frames, then forward to the physical layer which forwards these frames through a noiseless channel to the receiver. At the receiver, the physical layer receives the frame, then forwards to the data link layer which removes the header and trailer and forward the data to the network layer. So this process will be continuous until all the data which has to be transmitted from the transmitter or the sender is completed, and all the data to be received by the receiver is being received successfully. So remember, in simplest protocol, we are assuming that no data will be lost or corrupted or any duplicated. So here we doesn't require any type of flow control or error control, and that type of mechanism is called simplest protocol. Right. In simplest protocol, we just discussed that it will simply receive the data from the network layer, convert to frames, and forward to the physical layer by converting the datagrams into frames by adding header and trailer. The physical layer will forward the data to the noiseless channel and received by the receiver, and forwards to data link layer which removes the header and trailer and forwards the datagram to the network layer. Let us simply see an example to understand the illustration of simplest protocol. So here a figure shows an example of communication using simplest protocol. It is simple. The sender sends a sequence of frames without even thinking about receiver. The reason is simple, because we in the beginning of simplest protocol we discussed that whatever the data sent by the sender will be received by the receiver without any loss or duplication or corruption. So hence the sender will be continuously sending the frames. To send, in this example we have taken 3 frames, so the sender will have 3 events, that is sending frame 1, sending of second frame, and third sending of the third frame. The same way The receiver is also having three events: receiving frame 1, receiving frame 2, and receiving frame 3. Note that the data frames are shown by the tilted boxes. The height of the box actually indicates the transmission time difference between the first bit and last bit. Okay, so simplest protocol, sender has the data to transmit, it continuously transmits, and receiver can continuously receive the data that has been transmitted by the sender. Now let us look for an algorithm which explains how exactly the simplest protocol is implemented. First, we'll try to look at the algorithm at the sender side for the simplest protocol. Here, the data link layer will be waiting for receiving the data from the network layer. So while true means the net data link layer is waiting, what it is doing? It is waiting for the event. What is the event we are talking? We have been talking about an event of receiving the data from network layer, and until that happens, your data link layer will be in the sleep mode. Once the event has been generated, that is network layer requested data link layer to send the data to the destination. So once the request to send is received by the data link layer, it receives the data from the network layer, then convert that data into the frames by adding the header and trailer, which consists of source and destination address and some of the error detection and correction information. And once the frame is made, it will send the frame to the physical layer to forward through the channel to the destination. This is what exactly the set of events happen at the data link layer of the sender side. Wait for the event. Once the event occurs, receive the data, make the frame, and then send the frame. Now, once a frame has been sent by the sender side, this will be received by the receiver. Till that point, the receiver will be in the wait state. What is it is waiting for? To receive the frame from the sender through the channel. Once the frame has been reached to the receiver and forwarded by the physical layer to the data link layer, it will be receiving the frame. Then it try to extract the data by removing the header and the trailer contents, and after removing those parts, that particular set of data will be delivered to the network layer. This is the function that has been executed by the data link layer at the receiver side. So at the sender side, it receives the data, makes a frame, sends a frame. The receiver side, first it receives the frame, extracts the data, and delivers the data to the network. So the next type of noiseless channel protocol is called stop and wait protocol. So if data frames arrive at the receiver it is faster than the capability of its processing. So what receiver does it? It will be storing those frames until they are used. Normally the receiver does not have the enough space, especially if it is receiving data from multiple users. So when it is buffer is getting actually filled fast, it will ask the sender to slow down. So we need a feedback mechanism from the sender to the from the receiver to the sender. Okay, so in stop and wait protocol, the sender sends one frame, stops until it receives an agreement of the receiver. Okay, I have received it, you can send the next, and then only the sender sends the next frame. So here the data will be transmitted only in one direction, that is from the sender to the receiver, but auxiliary acknowledgements, which are confirmation of the receipt of the frame, will be traveling from the other direction, that is from receiver to the sender. So we add a flow control mechanism to the simplest protocol in case of stop and wait. So simplest protocol will have no flow control, no error control, whereas in stop and wait protocol it doesn't have error control, but we have a flow control mechanism. Let us look at the design of the stop and wait protocol. So as discussed in the previous protocols, the data link layer of the sender receives data from the network layer in form of datagrams. Then the data link layer adds the header and trailer, which consists of source and destination MAC address and also the information for error detection and correction. And after converting the datagram to a frame, this data link layer forwards the frame to the physical layer, which will forward this data frame to the receiver, through the noiseless channel. Now at the receiver receives the frame and forwards to physical layer, which forwards to the data link layer. The data link layer separates the header and trailer and forwards the datagram to the network layer of the receiver. Now, there is a small difference between simplest protocol and stop and wait protocol is once a transmitter has sent a frame, it will stop sending the next frame until it receives a confirmation from the receiver. At the same time, the receiver, after receiving the frame, along with forwarding the data to the data link layer, it will be generating an acknowledgement frame which will be traveling from the receiver to the sender. Once the sender receives the acknowledgement frame, then it will try to send the next frame. And this process continues until all the data that has been transmitted. If you could observe here, first the data link layer of sender is generating a frame and sending a frame and stopping the sending the next frame and waiting for acknowledgement. Only after receiving from the acknowledgement from the receiver, then only it is sending the next frame. That is the reason why we call this particular protocol as stop and wait protocol. So here the initiation starts when the data link layer of the sender receives a request from the network layer, and once it receives, it makes the frames, sends the frame, and waits until it gets the acknowledgement from the receiver, and once it receives it, it sends the next frame. At the same time, the receiver is also waiting for the event of receiving the frame from the sender. Once it receives the frame, it forwards the data by separating the header and trailer and to the forwards to the network layer. At the same time, it generates an acknowledgement frame and sends from the receiver to the transmitter. To understand the stop and wait protocol, let us consider a simple example. Here we have a sender referred with a variable A and the receiver referred with a variable B. And here the communication has been happening using stop and wait protocol. Once sender A's data link layer receives the data from the network layer, it converts into the frame and forwards to the receiver B. And sender waits until it gets the acknowledgement from the receiver B. Once the acknowledgement from the B is received, then it will send the next frame and again waits until the receiver receives the frame and generates an acknowledgement frame and sends back to the sender. So here the totally sender is having 4 transactions. One is making 2 frames and sending it and receiving the acknowledgements. And basically the receiver is generating 2 acknowledgements for the frames which have received. The important thing that we need to understand in stop and wait protocol is here we are ensuring that no data is overflown by ensuring only one frame is sent at a time, and next frame will be sent only when an acknowledgement for the previous frame is received. So this is how we are trying to implement flow control. Since we doesn't have any loss of data or corruption of data, error control is not required in case of stop and wait protocol. Let us look at the algorithm of stop and wait protocol at sender side. Initially, the data link layer is waiting for receiving the datagram from the network layer. So initially the status of data link layer is can send, that I would like to send the data is true. Now it is waiting for the event of receiving data from the network layer. Once it has received the data from the network layer, that event request to send has been generated and also the can send is true, then the data link layer will get the data and make a frame from the data by adding header and trailer and send the frame through the noiseless channel, and immediately after sending the frame it will make the condition can send equal to false. Why is this particular thing happen? Because in a stop and wait protocol, data link layer would only send the next frame when it receives a positive acknowledgement from receiver. Until that time this can send will be in the false state, and now after sending it and making a can send equal to false, it is waiting for an event. What is the event here? It is waiting for an event of receiving an acknowledgement from the receiver. Once an acknowledgement is received from the receiver, then it will make the can send condition again to true so that it can send the next frame. This is how an algorithm for stop and wait protocol is implemented at the. Let us look at the algorithm for the stop and wait protocol at the receiver side. So at the receiver side, the data link layer is waiting for an event. What is the event? Receiving a frame from the sender. Once the data link layer receives the frame from the sender, it will try to extract the data by removing the header and trailer and forward the data to the network layer. At the same time, the data link layer would also generate an acknowledgement frame and send it to the transmitter so that the transmitter can send the next frame. The previous slide, we tried to understand the stop and wait protocol, which gives an idea of how to add flow control to its predecessor. But the first two protocols which we have discussed, that is simplest protocol and stop and wait protocol, are for the noiseless channels, basically which are not existent in the nature. Definitely the channels which are present are noisy channels. What do you mean by noisy channels? The channels in which the frames sent can be lost, corrupted, or duplicated are known as noisy channels. So there is a definite chance that during the transmission a frame can be lost, corrupted, or duplicated. So when your channel is noisy channel, to handle the flow control, we have three types of protocols that use error control along with flow control. What are the three types of protocols used for the noisy channels? Stop and wait, automatic repeat request, go back in, automatic repeat request, and selective repeat, automatic repeat request. Before we go into the details, let me tell you a simple important terminology called automatic repeat request is a process of error correction in which whenever a receiver detects an error present in the received frame, instead of correcting the data, it will ask the sender to retransmit the same frame. It will be happening in two ways, either informing the sender about the damaged frame received or not sending an acknowledgement, and that makes sender understand that there is some problem with the frame sent, and the sender will be retransmitting the same frame. So we have three types of protocols in noisy channels, that are stop and wait ARQ, go back and automatic repeat request, and third one is selective repeat ARQ. The noisy channels are those kind of channels in which the frames can be lost, corrupted, or damaged. So to handle those kind of channels, we are using special set of protocols. The first type of protocol used for noisy channel is called stop and wait automatic repeat request. This is an extension of stop and wait protocol which we have discussed in the noiseless channels. But here there is a possibility that a frame may be lost, corrupted, or damaged. To handle that, we are implementing an automatic repeat request mechanism. So error correction in stop and wait ARQ is done by keeping a copy of the sent frame and retransmitting the frame when the timer expires. What do you mean by this? In stop and wait ARQ, whenever a sender sends a frame to the receiver, then immediately it starts a timer. And before the timer reaches 0, it expects the receiver to send a positive acknowledgement. In case if the sender is not able to receive the acknowledgement or it receives a negative acknowledgement, then after the expiry of the timer, the sender will retransmit the same frame. In stop and wait ARQ, we use sequence numbers to the frames. So whatever the frames we are transmitting by the sender, they are given certain sequence numbers. The sequence numbers are based on modulo 2 arithmetic. What do we mean by this is the frames are given numbers 0, 1 alternatively. Okay. In the stop and wait ARQ, the receiver confirms the receipt of the frame by sending an acknowledgement number, which also uses modulo 2 arithmetic, and it will indicate what is the next frame that sender is expected to transmit. Now let us look at the designing of stop and wait ARQ protocol. Now the data link layer will be initially waiting for the event of receiving the data from
network layer. Once the network layer sends the data to the data link layer, it converts it into a frame by adding header and trailer. Along with the header and trailer, here the data link layer will be giving a sequence number to the frames. As mentioned in the previous slide, the sequence numbers will be modulo 2 arithmetic with alternatives 0 and 1s. Now first let us plan to send a frame with a sequence number 0, and once the sequence number 0 frame is generated, it sends the frame through the physical layer to the noisy channel. And immediately after sending the frame, the data link layer will be starting a timer, and it will be using a certain time period before which it expects a positive acknowledgement from the receiver. Once the frame is sent and received by the receiver, in case if no error has been identified by the data link layer, it will be extracting the data, removing the header and trailer, and deliver the data to the network layer. At the same time, once it receives a frame without error, it sends a positive acknowledgement to the sender. And once the sender receives a positive acknowledgement before the expiry of the timer, it will be completing its frame transmission and will try to send the next frame with a frame number 1. Remember, in the stop and wait ARQ, when a sender sends a frame, it keeps a copy of the frame until it receives the positive acknowledgement. If it receives the positive acknowledgement, it will discard the frame which has been sent. If it does not receive acknowledgement or receives a negative acknowledgement, it will retransmit the same frame. This is how a stop and wait ARQ protocol is implemented.
Let us look at an example of stop and wait ARQ protocol. The sender A would like to transmit the first frame with a sequence number 0. Now, once it sends frame 0, the sender A does two tasks. The first one is it starts a timer and it expects that it receives a positive acknowledgement from the receiver before the timer reaches to 0. The second thing that's by the sender A is it keeps a copy of the frame 0 so that if it does not receive acknowledgement or it gets a negative acknowledgement, it can retransmit the same frame. The receiver once receives the frame 0 and it finds there is no error in the frame 0, then it extracts the data and delivers the data to the network layer. At the same time, it will try to send a positive acknowledgement to the sender A. If you refer to the acknowledgement number is 1, which is indicating that I have received frame 0 successfully and now I am expecting acknowledgement 1, means I am expecting frame 1. Once the sender receives the positive acknowledgement, now it tends to send the frame 1. So the sequence number initially was 0. Now after receiving the acknowledgement, it becomes sender sequence number as 1 and it transmits the frame 1. As we said, the stop and wait ARQ is implemented in a noisy channel where there is a possibility of frame getting lost, corrupted or damaged. In this scenario, the frame 1 was transmitted by the sender but it got lost before it reached to the receiver. And because the frame 1 is not reached to the receiver B, it does not send any acknowledgement to the A. So what happens here? The timer which was started now reaches to 0, still we did not receive any positive acknowledgement. So the sender makes an interpretation that either the frame is lost or got corrupted, and so it tries to retransmit the same copy of the frame which it has kept before sending to the receiver. So frame 1 will be resent, and receiver, which was expecting the frame 1 to be received, receives that, and now after receiving the frame 1, it will send an acknowledgement 0 indicating that now frame 1 is received successfully. I am now expecting the frame 0. So here the sender whose previous sequence number was 1, now after receiving the acknowledgement, its sequence number becomes 0 and now it sends frame 0, starts the timer and keeps a copy of the frame 0. It has reached to the receiver, it was expecting frame 0 and then it sends an acknowledgement 1 indicating now it is expecting a frame number 1. But in this scenario, instead of the frame, we could find the acknowledgement frame sent by the receiver has been lost. And because of this, even after the timer expires, the sender does not receive the positive acknowledgement. Now, sender was not sure whether the data was lost or it has been corrupted or acknowledgement has been lost. So because it has a dilemma about the status of the frame 0, so it is going to retransmit this same frame 0. And now the receiver, after receiving frame 0, it knows that it was expecting frame 1, but it received frame 0. So it again tries to send an acknowledgement and try to inform the sender that I am expecting to receive the frame 1. So this is how a stop and wait ARQ protocol is implemented. First, let me quickly make a revise of what we have discussed. So here the figure shows an example of stop and wait ARQ protocol. Frame 0 is sent and it got a positive acknowledged. Frame 1 is sent but it is lost, and after the timer expires it has been resent and it got a positive acknowledgement from the receiver. Next, frame 0 is transmitted but its acknowledgement got lost, so the sender is not sure about whether the frame is transmitted successfully or not, so he tries to resend the same frame. This is how stop and wait automatic repeat request is implemented. Why we are calling it as stop and wait? Once a frame is sent, the sender is waiting until it gets an acknowledgement. So it is stopping its sending of the frames and waiting for acknowledgement. And why we are calling it as automatic repeat request? Whenever the frame is not able to receive the acknowledgement before the timer expires, or even the acknowledgement for that has been lost, it is retransmitting the same frame instead of new frame. That is called automatic repeat request. Combining these two mechanisms, we refer this protocol as stop and wait ARQ. So far, we have discussed about stop and wait ARQ, and simplest protocols. So here, in stop and wait ARQ, you could find at any instant of time, only one frame is sent, and once the frame is sent, the sender will be waiting until receiving the acknowledgement from the receiver. So it sets a timer, keep a copy of it. The frame is received successfully, it will send the next frame, else it will retransmit the same frame. Now what we could observe in the so far mechanisms is only one task is involved. But if we are trying to plan to send more than one frame at a time, that is, a task is often begin before the previous task is completed. What is the task here? The second frame is sent before the acknowledgement of the first frame is received. Then that kind of mechanism will be referred as pipeline. In our stop and wait ARQ, we doesn't have this pipelining mechanism, and we will find the sender waiting for the acknowledgement before sending to the next frame. So what happens if we implement pipelining in our mechanism is it will improve the efficiency of the transmission of number of bits. It will be large with respect to the bandwidth delay. So if more than one user is trying to utilize the channel will be effectively utilized, and definitely you will find the efficiency of the channel will be much more. So that is the reason why we are going to prefer pipelining to be adapted in the transmission. The next two protocols, particularly go back and ARQ and selective repeat ARQ, they are going to implement pipelining by sending more than one frame at a time before waiting for the acknowledgement of the first frame. So this is what meant by pipelining concept. So we'll try to stop our class here, but let us try to recollect what are the different things that we tried to discuss in our today's class. We started our discussion with what do you mean by flow control and what do you mean by error control, and the flow control and error control together with framing and protocol scenario is referred as data link control. So what do you mean by flow control? It need to ensure how many frames can be set before waiting for acknowledgement. Error control is a combination of error detection and correction. Protocol is a set of rules and procedures that govern the data communication, and the protocols are classified into two types: noiseless channel protocols, where you expect the channel is free of loss, damage or corruption, and here you have two protocols: simplest, in which sender continuously transmits and receiver continuously receives, there is no confirmation or acknowledgements, and it's a unidirectional protocol, and whatever the data sent by the sender will be received by the receiver So there is no flow control or no error control mechanisms in simplest protocol. The next type of noiseless channel protocol is stop and wait protocol. It's a bit different from simplest. Here, at any instant of time, sender sends only one frame, and once he sends the frame, he will wait until he receives an acknowledgement from the sender. And once he receives an acknowledgement from the sender, he will transmit the next frame. So, say, stop and wait protocol, we will have a flow control mechanism. But here also we assume the channel is noiseless, so there is no loss or damage or corruption of the frame. So no error control is required in stop and wait protocol. The next type of channel we have is noisy channel, where there is a possibility that the frame which is transmitted can be lost, corrupted, or damaged. And this is the practical channel. So when you talk about noisy channel, we have three different sets of protocol. The first and most is an extension of our noiseless channel protocol called stop and wait. Here we assume there is a probability that there is a loss of frame or corruption of frame. So we will try to implement a process called automatic repeat request, in which whenever the sender has sent a frame, it starts a timer and keeps a copy of the frame, and it expects a positive acknowledgement from the receiver before the timer expires. If the timer does not, sorry, the receiver does not send a positive acknowledgement before the timer expires, the sender will retransmit the same frame. But if it receives a positive acknowledgement, it will send the next frame. The last thing that we try to understand in our class is pipelining, in which more than one task will be implemented before the end of the first task. So we'll try to make the effective utilization of channel by doing multiple tasks. That process is called pipelining. So pipelining will not be present in the stop and wait ARQ because only one frame is sent, and it next frame is only sent when we get an acknowledgement. So pipelining will actually help in sending more bits through the channel and make it more efficient. Fine. So pipelining, we have two different protocols which are being implemented. Those are called as go back and automatic repeat request, and selective repeat and automatic repeat request. These two protocols we are going to discuss in the next class, and I hope you people have understood the two concepts which are covered today. Make sure you understand this, go through it. Any doubt we can clarify, because these are one of the very important topics in your unit number 2. Meet you in the next class.